For this set of instructions, for this set of problems, the instructions say classify the triangle by its angles. So we've got angle markings in these pictures for these triangles. Sometimes they'll only mark 2 out of 3 angles, and then they expect you to remember that the angles of a triangle, they always add to 180, so you can find the missing angle if there are any missing angles. Remember that a box in the corner means that the angle is 90 degrees. And our choices for classifying by angles is acute, right, obtuse, and equiangular. So remember, acute when they're all acute, right when there's one right angle, obtuse when there's one obtuse angle, and equiangular when they are all the same. So looking at this picture number 5, we've got a right angle in the corner, so this is a right triangle. It's pretty basic here. All 3 of these are less than 90, so this is an acute triangle. Number 7 is obtuse because it's got this 100-degree angle in the corner here. And then on number 8, they're all the same, and you should try to remember if they are all the same that they are all automatically 60 degrees. So that one is equiangular. Remember that these problems wanted a name for the angles, so you have to think of your list of possible angle names and only choose from those. So I'm going to move this down. This one's a little bit more challenging. We are using the distance to classify triangles. It's telling us to plot the points to form a triangle and to classify it based on its sides. So we're going to need to know, are any of the sides the same or anything like that? And then, is the triangle a right triangle? So I'm going to start by plotting the points. A is at 3, 1, and they counted by 2s, which is kind of weird. So 3, 1 would be here in the middle. Let me see if they'll all fit. 1, 2, 3, 4, 5, 6. They won't all fit if I count by 1, so I'm going to have to go by their 2s. So 3, 1 is where A is at. B is at 3, 4. And C is at 7, 1. So there's C. So I've got my triangle ABC. I'm going to connect the sides with some segments. A little bit poorly drawn there, but that's okay. So to figure out based on the sides here, these are vertically, since they're both at x values of 3, this is a vertical line, even though it really doesn't look like it. And this would be 2 and then 1 more. So this length of AB would be 3 in length. Since A and C have the same y value, this is horizontal. It's a horizontal line. And it goes from 3 to 7, which means that it's 4 across. So I've got those 2 sides. And then this third side, and since this is vertical and this is horizontal, I can use this as like a stair step to find this using Pythagorean theorem. And this is a Pythagorean triple, so you could also do your a squared plus b squared equals c squared. You would get 9 and 16 here, and that would be 25. And when you square root that, you'll see that that third side is 5 across. So, and also, since this is vertical and this is horizontal, these are making a right angle, and that was why we were able to use those sides to find the third side. So none of the sides are equal, and since we need to name it based on sides and angles, we need to know that. This is scalene because all the sides are different. And since it makes this right angle, it's a right triangle. So it is a scalene right triangle. That would be the classification based on sides and angles. So let's look at the one beside here. This one is at 1, 1 for A. B is at 4, 0. And C is at 8, 5. And connecting the dots here. So, looking at these sides, I don't think any of them are close to the same, but I'm going to figure out what they are anyhow just to be really sure. If I'm drawing in little stair steps here, making a right angle, so I can use Pythagorean theorem to find that length. This would be 1, and this would be, let's see, from 1 to there, 3 across there. So it would be 1 squared plus 3 squared equals c squared. That'd be 1 and 9. So 10 would be c squared. That'd be the square root of 10. And I don't have a calculator on me, so I'm just going to leave it at that, just to see if they're the same or not. And then over here for BC, I would draw in this right triangle with, remember they counted by 2s, so it's weird. Vertically, this is up 8, and this is across, oh no, that's up 5. Vertically, it's at 5. Counting by 2 is really messing me up. This is vertical distance of 5, and this goes from 4 to 8, so this is 4 across. So I've got 4 squared and 5 squared, which would be 16 and 25, which would be 41. So the square root of 41 is that distance. And then for the last one of the side lengths, let's see, I'm going to draw it up here. So let's see, this is up here at 5, this is at 1, this is a vertical distance of 4, and this is also at 1 and going over to 8, this is a distance of 7. So I've got 4 squared and 7 squared is 16 and 49. So that's 65, so that side length would be square root of 65. So I can see, and I've showed all my work, so I would expect to see you doing this kind of work on your paper as well. To find these distances, we've been practicing that for a good while. All of them are different, so it is scalene. Now we need to figure out what kind of angle it is. It looks obtuse to me, and the way that I'm going to sort of verify that is by finding the slope of one of the lines and drawing the line that would be perpendicular to that. So let's use BC for example. The rise on this is 5 and over 4. So if I want to be perpendicular to that, I need to flip it to be 4 over 5, and I need to go negative. So I need to go down 4 and over 5 from B to make a perpendicular line there. So it's counting by 2, so 2, 4, 2, 4, 5. This would be another point on that line. I'm going to draw this line in green through B. This is the perpendicular line to BC. Notice that this triangle, this side of it, is beyond this green line. The green line would make a right angle here with that segment, but since this goes beyond it, this is actually an obtuse angle, so it's a scalene obtuse triangle. Now sometimes you can get that answer with doing a lot less work, I know, but I want to show this for my regular students to know, every little bit of the work that you could do to show each piece, and also for pre-AP, because I would expect to be seeing this type of work on like a pre-AP proof if you were having to prove your work and show and justify everything.